Good morning, guys. We will talk about in this video. We will talk about class 10th metal and non-metal chapter. In our earlier video, we deal with reaction of metal with water with so many different examples. In our earlier class or in earlier video, we discussed that so many metals different behave shows the with the solution with the water. In this series we may continue about the reaction of metal with water. Firstly, we took only react with steam. For example, if we talk about metals, they may have different type of behavior. In this first case, only react with steam. If we talk about only react with steam, for example, metals are like iron, zinc, aluminium. They react with water and behave as they react with water with the steam condition and form metal oxide and release hydrogen gas. And some metals, they do not release hydrogen gas. For example, we will talk in this zinc react with steam and it produce zinc oxide in solid with hydrogen gas and release with hydrogen gas. For another example, we will took that aluminium. In aluminium, with the reaction of steam, it form aluminium oxide Al2O3 in solid condition and produce H2 gas. In I have earlier told you that all metals have different type of behavior, different kind of behavior. With the example of metal with water or steam, in the steam we will took the further example like Fe react with hydrogen gas. Fe react with hydrogen gas. We will we will take steam. In this case, Fe it became in product form iron Fe3O4 in solid case and release hydrogen gas. Iron second third oxide became. Okay, we'll discuss the next type of this. In reactivity series, like copper, silver, and iron, they they behave different kind of behavior. In the reactivity series, some metal they lie bottom in the reactivity series. For example, copper, silver, and aurum, gold. They do not react to it any case, even in the higher extreme case or in the lower extreme case. They do not react with metal at any case. um, in the reactivity series, for example, potassium, sodium, aluminium, zinc, and so many others, and so many on, we'll talk in this video later. Reaction now we move to the reaction with dilute acid. In metals, reaction with dilute acid. In further, we will discuss metal with water, metal with oxygen, metal with another behavior. Now we talk about reaction with dilute acid. We in this dilute reaction with metal in dilute acid, we will take metal with acid and it forms salt and hydrogen gas, next. um, we'll took a reaction and show and see its behavior. In reactivity of metal, it different with same acid. in reactivity of metal is different with same acid. In the reactivity series and the same metal, they may take different they may behave as different kind of behavior. With the same metal or element, they behave as a violently, or some behave like slowly behavior, and some react vigorously, and some behave so they do not react with highly reactive or highly vigorously behave with dilute acid. It may different behavior. It may seem different behavior with dilute or concentrated also. For example, acids like HNO3, H2SO4, or HCl, hydrochloric acid, H2SO4 like sulfuric acid, and HNO3 like nitric acid. They all kind of acids, it may behave with different metals. For this reactivity, we'll take an example like sodium, magnesium, and calcium. I have earlier told you that they all behave different kind of reaction with metals. Like sodium, magnesium, and calcium, they react violently and and form HCl in dilute, and with the form of HCl dilute and H2SO in dilute case, and give hydrogen gas. I'll repeat. In reactivity of metal is different with same acids, for example, sodium, magnesium, and calcium, all the metal react violently with dilute hydrochloric acid and sulfuric acid in dilute case, and give hydrogen gas. But in the same case of we will discuss Fe and Cu, iron and copper metal, they react slowly. Fe, iron reacts slowly with HCl and H2SO4 acid. But in the case of copper, it does not react with the acids. With the same of acid, we talk only about sulfuric acid or nitric acid. We sulfuric acid or hydrochloric acid. We did not discuss about HNO3. HNO3 because the HNO3 nitric acid does not does not give hydrogen gas. If it react with any metal, it behave it gives oxidizing agent. It form not hydrogen gas, but it form H2O. It form H2O because it gives oxidizing agent. In HNO3 nitric acid, it behave different. So in this kind of behavior, we does not take HNO3. We more often go with the H2SO4 and HCl. They give hydrogen gas. But in our chemistry, some exceptions are always available. So if we took manganese or magnesium, it may give hydrogen gas. And next we talk about aquaresia, next type of our topic, aquaresia. It behave it behave corrosive or furious with the metals. Corrosive or furious behavior are with the metals. In this aquaresia, we will talk concentrated HNO3 and 3 concentrated HCl and 3 concentrated HCl in 1:3, HNO3 nitric acid and HCl hydrochloric acid. They both can dissolve even highly not reactive metal like gold and platinum. They even can dissolve gold and platinum metal. Later we move on to the next part of our behavior of metal. Reactivity of metal with salt solution. Reactivity of metal with salt solution. More reactive metal placed in salt solution of less reactive metal. Obviously, the more reactive metals placed, the less reactive metal with their behavior. The kind of behavior they shows in the reactivity series. As I earlier told you, for example, in reactivity series, calcium, potassium, sodium, calcium, magnesium, aluminium, zinc, ferrous or lead, hydrogen, and copper, mercury, and gold, and silver and gold. And lastly, the gold. They shows the highly reactive behavior to the less reactive behavior. This is the reactivity series. In this the reactivity series we can learn is with the some mnemonics like kana, kalu, mange, alu, jaan, fir, pub, kyun, hanji, and so many different kind of mnemonic we can make, or with the help of another things. Okay, we move to the topic first. Reactivity of metal with the salt solution. In this case, reactivity with the metal with salt solution. More reactive metal placed in salt solution of less reactive metal. It behaves like a displacement reaction, as we can say that the more reactive metal displays the less reactive metal and form its salt solution. Let's take an example of this. Zinc and CuSO4. Zinc and in the uh, in the reactant zinc and CuSO4, it make product of ZnSO4, zinc sulfate and copper. Zinc sulfate and remove or displace copper. With the same thing, if we took a different type of kind in this reaction, because we know the zinc is highly reactive than copper as compare of copper. Zinc behave different kind of behavior, and copper is less reactive. And then if we take this example uh, uh, in opposite direction, for example ZnSO4 and copper with copper, then it may does not behave like a displacement reaction, because zinc has highly reactive than copper. Zinc is highly reactive than copper, then the reaction does may not complete, the reaction does may not proceed. Okay, I hope I hope you get my point. In the reactivity series I have earlier told you that potassium, calcium, potassium, sodium, calcium, magnesium, aluminium, zinc, ferrous, lead, hydrogen, copper, mercury, or silver, and gold. In this reactivity series, you may have to learn this series because it is very helpful in our chemistry, or it is very useful for some reactions we can deal with. So hope you guys you will understand this part of metals reaction with water. Now with this video we complete the metal chemical properties with the different kind of oxygen, water, and so many behavior with the stream condition, with the water condition, and with the vigorous effect or with the slow property. So in our next video we will talk about non-metal. So for this, bye bye. Hope you guys enjoy the session. Please like, share, and comment your views on this video.